This video is on graphing polar functions, particularly limesons. So we're going to start by completing a parent table for r equals cosine theta. And even though we're using the variables theta and r, it's not any different than using theta and y, or x and y, that we've done on other problems. So the general angles that we want to use here are 0 and pi over 2 and pi and 3 pi over 2 and 2 pi. And then hopefully you remember the pattern for the cosine function. Just thinking about it to help you remember it, at 0 the cosine, which is the x-coordinate, is 1. And when you're at pi over 2, the x-coordinate is 0. And when you're at pi, the x-coordinate is negative 1. At 3 pi over 2, the x-coordinate is 0. And at 2 pi, the x-coordinate is back to 1 again. So the transformation here is nothing on theta, so this will just stay the same values, 0, pi over 2, pi, 3 pi over 2, 2 pi, and then this will be 3 plus 2 times the r values. And so this one will change to 5, 3, 1, 3, 5 by taking these r values and putting them into this expression. So the regular graph, if we just call this r and theta and graph this on a rectangular coordinate system, the graph would look as you would expect it to. 1, 2, 3, 4, 5 over pi over 2 and up 1, 2, 3 over pi and up 1 over 3 pi over 2 and up 3 and over 2 pi and up 5. And the curve looks something about like this. Now you don't really need the rectangular graph in order to graph the polar function, but I think it's kind of nice to look at this graph as you visualize what's going to happen over here. So first we could plot these points. The angle, this is supposed to be a theta here. The angle is 0 and the radius is 5. So that would be 1, 2, 3, 4, 5, this point right here. And the angle is pi over 2 and the radius is 3. 1, 2, 3. And the angle is pi and the radius is 1. The angle is 3 pi over 2 and the radius is 3. So that's all the points from the parent table, and that is enough to sketch the graph once you gain a little familiarity about what shapes you might be able to get from graphing polar functions. So the way to get a few more points on there, that's why it's kind of nice to have this graph here. So if you go over to this horizontal line or scale here at pi over 4, you can estimate from this curve that the y value or the r value here is about 4.5 maybe. So if I come out here to the pi over 4 angle, I can go out to 1, 2, 3, 4.5 to get another point on the curve. And then same over here, if I'm at 7 pi over 4, I'm also out to about 4.5. 1, 2, 3, 4.5. So that makes it a lot easier to sketch the curve in this region. And then also if you came over here to 3 pi over 4, you can tell you're up maybe about 1.5. So 1.5 is about right here. And at 5 pi over 4 would be right in here, also about 1.5. No, I didn't actually look those up to see what they were. I just know that they're close enough. for our purposes of sketching this curve. So I'm going to go ahead and sketch it here, but pay attention to the fact that first the R values are 5, and then they're getting closer to 1, and then after we get to 1, right here, they're going back out to 5 again. So they're positive all the time, and you just get a curve that looks something about like this. And the closest it ever gets to the pole, the origin or the pole, as it's called with polar coordinates, is right here at 1. And then after that, it comes back out just a little bit. The most common error in sketching these graphs is to not make them round enough. It's not looking particularly pretty there, but good enough for our purposes. Okay, so that's the first curve there, and in a moment I'll show you, well, let's do this. If you wanted to see how to do that on your graphing calculator, you can change your mode to polar mode, coming down here and selecting polar. Now when you go to y equals, you will have r equals, and you can put in the equation 3 plus 2 cosine theta, and when you press the xt theta button, now it will say theta. And then you want to set your window up so that you can see the whole graph. So this is saying it's going to graph theta values between 0 and 2 pi. 6.28 is about 2 pi. It's going to plot points at about every 0.13 radians, so that's fine. And it's going out, up and down to -10 and left and right to +10. I'm going to change those. Our largest x value is -6. And x-min -6. Oh, I used the wrong negative sign. And +6. And then I'm going to do the y's only to -5 and +5. I think that'll be a nice window for this graph. Make sure we're in radian mode, in radian here, and graph it. So that's pretty good. It's a little bit egg-like shaped sideways because the scale, this x scale, is stretched a little longer than this y scale for the window I chose. So I'm going to do a zoom square and see what happens to the graph from there. Alright, good. That's a lovely window for that function. So you can see it dips in just a little bit here that my curve doesn't show so nicely, and it's nice and round. Students tend to make theirs too skinny looking. So as you try and sketch your curve, always think, make it round, make it round. Alright, let's try the next one. I'm going to fill out this table and then turn the video back on. Alright, so I have the parent table and the transform table all filled out. I'm plotting the points over pi over 2 and up 1, 2, 3, 4, over pi and up 1, over 3 pi over 2 down 2, and over 2 pi and up 1. So the curve looks about like this. And now we need to graph this function. So what makes this graph a lot more interesting than the previous one is this portion that's negative. And remember, when you graph negatives on the polar graph, that they go the opposite direction than their angle. So the 0, 1 point is here, and the pi over 2 point 1, 2, 3, 4 is here, and the pi point is here at 1. But the 3 pi over 2 point, that's -2, instead of going down toward our 3 pi over 2 angle, we're actually going to go up 2 units inside of the graph. And that makes the graph look a lot different. So in order to get some more points on here so we can figure it out, let's kind of step through here. If we go to pi over 4, looks like we're out at least to a little more than 3. So 1, 2, 1, 2, 3, and a little bit more. That's just based off of my sketch over there. And 3 pi over 4, a little bit more than 3 as well. And so it starts off and it does this. If I highlight this graph here, this portion that I'm going over in green right now, I can do it with another, this portion here is this right here. Sorry, those just aren't very pretty. It's hard to draw with this. Then after that, when I'm in this region right here, past pi, but before I get to 0, there's this little bit. There's this little bit here. That's going to be this little bit here. And then it goes to 0. And then after that, this part here, this purple part, is this loop inside that comes up and comes back around, and then let's go back to orange for this little bit, is this little bit right here. So I know it has a loop inside because this graph goes negative, so it has to kind of turn in on itself, whereas this graph up here did not have a loop inside because all of the R values were always positive for the whole graph. Okay, so I know that that can be confusing. After a little bit, I think you'll get more used to it, and you could explore different functions on the graphing calculator too. So if we change this to 1 plus 3 sine theta and graph it, we can see the function. And there's the nice little loop inside. And you could play around with that and see what happens. Like maybe if you made this a 2 instead of a 3. You still get the loop inside. And let's see, if we made this a cosine instead of a sine, the graph looks similar, but see how now it has a line of symmetry along the x-axis instead of the y-axis? You can kind of see that. You can see that in your graphs if you check this out. Let's say, I think, see here there's a line of symmetry at pi. Here's pi. Here's a line of symmetry for that graph. On this graph there's a line of symmetry at pi over 2, and on this graph there's a line of symmetry at pi over 2. Okay, done for now. You should try a few of these problems on your own in the textbook before listening to the video for the second half of the functions.